Yes, let's continue with some other reactions of diazonium salts. Next, we have replacement by iodine. When diazonium salts are treated with the potassium iodide aqueous solution and they are heated, they result into substitution by iodine here. So you will get here a simple method for generation of iodobenzene. Fine, along with the removal of nitrogen, potassium iodide. Fine. So this is again a suitable reaction to form iodobenzene. Fine. Another is the most important, that is substitution by fluorine, replacement of nitrogen by fluorine. Now this is the best method for generation of fluorobenzene. As fluorobenzene is very difficult to prepare by simple electrophilic substitution reactions of benzene, with which you can easily prepare chlorobenzene or bromobenzene, but it is very difficult to prepare fluorobenzene. So in this method, diazonium salts are treated with fluoroboric acid. Here first you will get this salt, that is benzene diazonium fluoroborate. So this salt is further heated and it results into loss of nitrogen molecule as well as BF3, and you will get fluorobenzene. So one of the very useful method for preparation of fluorobenzene. Fine. Another useful reaction is the generation of nitrobenzene, substitution by NO2 group. So again the first step followed is this, that is up to preparation of benzene diazonium fluoroborate. It is further heated with sodium nitrite and copper to give you substitution by NO2, that is you will get here nitrobenzene. Fine. So along with these byproducts, so we have done that using diazonium salts we can, number one, prepare all kind of aryl halides, that is substitution by chlorine, by bromine, by iodine and by fluorine. Then number two, using diazonium salts you can prepare cyanobenzene, with the help of which you can prepare so many other compounds. You can enter into family of amines, in the family of carboxylic acids, in family of aldehydes, amides, etc. And then you can also prepare nitrobenzene, with which you can further reduction of nitro, you can again get aniline. Fine. So the most useful reactions we have discussed. All these reactions were common in the sense that in all these reactions there is replacement of nitrogen by some other atom or group of atom, and all these reactions were taken up as a result of heating diazonium salts. We know diazonium salts are unstable, so they easily result into removal of stable molecule of nitrogen, which can be easily substituted by some other atom or group of atom. Now we will discuss a second type of reaction in which nitrogen, that is the azo group, is retained in the diazonium salt. So obviously if nitrogen has to retain in the diazonium salts, then the reaction will definitely take place at a very low temperature, that is in the range 0 to 5 degrees Celsius, where diazonium salts are stable. Fine. So we have important reaction in this category is coupling reaction. Fine. So I have already discussed this. Once again, in coupling reaction, diazonium salts, first coupling is with the phenol. The coupling reactions are very useful in dye formation. In azo dye industry these reactions are very useful. Fine. So when it is treated with the phenol, it's a very low temperature range. The medium in this case is a slightly basic medium, the pH is 9 to 10. So as a result you get here azo dye of this formula. This is an orange colored Done. Fine. So you can name it. This is a para hydroxo azobenzene. Para hydroxo azobenzene. It's orange colored dye. Second is diazonium salts can be easily coupled with another aromatic compound, that is aniline. In this case, the medium is slightly acidic in the pH range 4 to 5. Loss of HCl. I am going to write the overall product, fine, which is the rearranged product here. So in the similar way, here also there is formation of para amino azobenzene. This is para amino azobenzene and it's a yellow colored dye. Fine. So this is the very important reaction in which nitrogen is retained, and such reactions take place at a low temperature range, otherwise the nitrogen cannot be retained. You know, diazonium salts are very less stable. Fine. Now next we will take up some synthesis of some compounds in organic which are otherwise very difficult to prepare by traditional methods. For example, I will start with some unusual synthesis. First we have synthesis of 3,5-dibromotoluene. We have to prepare, this is 1, 2, 3 and 5, 3,5-dibromotoluene. Now you see, this compound is very difficult to prepare. As we know, alkyl groups attached to benzene ring, they are ortho and para directing in nature. Fine. But you see the position of two Br here, both are present at meta positions. Fine. So let's see how we used to prepare this compound. The starting material for the preparation of this compound is para-toluidine, which is available, para-toluidine, right? Now para-toluidine is first, it is treated with bromine aqueous, fine, and we know when NH2 group is present on the ring, all the positions, ortho and para position, they are highly activated for electrophilic substitution, which we have already discussed in aniline. So there will be bromine at all available positions at ortho and para, but para position is already occupied, so there will be Br at all the available ortho positions. Fine, very interesting. Now further, now if you see, we are very close to this compound, only we have to remove this NH2 in this conversion. Fine, so we can do it. First let's convert this into diazonium salts. This is the condition of diazotization reaction. Diazonium salts, fine, you have got diazonium, and you also know that this group can be removed, can be substituted, can be replaced by hydrogen by deamination reaction, that is H3PO2 in the presence of cuprous salts, or you can use ethyl alcohol for this reaction. Fine. So this is substituted by hydrogen. So in other way you can say this group is totally removed. So you get the desired product. This is 3,5-dibromotoluene. Fine. So this is unusual synthesis, but we are able to prepare this through diazonium salts. Fine. So I'll take up another one. Second synthesis we have is second compound is 1,3,5 tribromobenzene. We have to prepare this compound. This is 1,3,5 tribromobenzene. You cannot prepare it by direct bromination of benzene, right? So let's start this preparation from the available compound, that is aniline. You can prepare this compound from aniline. So you can have a conversion in exam, convert aniline into, this is 1,3,5 tribromobenzene. So it's very simple. First